Here's the very final video on radiation, not bringing new aspects, just summarizing the procedure to solve radiation tasks. Well, this subject is really very well suited to be tackled in a right comprehensive and ordered manner. And for this, I recommend you to follow these 5 steps that are shown here to solve radiation problems. Let me pick here the laser pointer. So problem analysis, balance, then surface brightness definition, view factor definition, setting up, solving and remodeling. Let's first start with problem analysis and what needs to be considered there as well. For example, we need to first study which parameters are given and which ones are wanted. We need to look into, is a spectral formulation necessary? Is there diffuse radiation involved or not? Are several bodies involved? Let's first start with the spectral consideration. That may come into play. Maybe there's radiation from our source, black body radiation, for example. If we use a filter and then some short wavelength radiation may be missing, so we would only consider it up above a certain wavelength. We could use a slit or something that is cutting out something in the middle here to have here, let's say, the band between 1 and 1.45 micrometer be cut off. So that's something we need to consider. Then is the object that radiating diffusely, or does it just have a direction? One important direction to be noted is if we have sun radiation, we know the effect of having a shadow. Well, then we would assume that in the shadow no radiation would be present from this object. Several bodies involved. The last video talked about 3 objects. Now here we need to understand how many there are, go back and determine, can we group them together? Can the wall be grouped together with something else, or do I really need to deal with 3 objects here? Well, the next thing would then be the balance. For the balance, we need to first understand how many balances do we need. Then we need to establish either an inner or an outer balance, and then we can write it down, and that's what I recommend you to do, to use the surface brightness method. You can also do the net radiation flux, where then the surface brightness will come as the second step. I did that one in the 3-body project, 3-body or 3-object problem. You can have a look there. Now, surface brightness, there are 2 examples. We have made here the charcoal example with a glass on top, and remember, the surface brightness is the own emission plus reflection plus transmission if present. So in this case, the glass has 2 sides, an upper and a lower, and we can determine surface brightness for both. So we have radiation from the charcoal that hits the glass, gets reflected or is transmitted. And the glass radiates itself due to its own temperature, and it is emitting radiation. So the upper surface brightness, or the surface brightness of the upside, contains own emission and transmission from the charcoal. The lower side contains emission from the glass plus reflected radiation from the charcoal. So keep this in mind, and the method of choice would be as done here. Sketch the problem, draw the control volume, and put everything in that's needed. View factors. We can determine view factors using the summation rule, reciprocal rule, symmetry, auxiliary planes. We did train that in a specific video. You see here a few panels from Heat Quiz where the question is for the view factors, or you can go and take the diagram from the formulary. We have presented there 2 diagrams to be used for rectangular configurations. And at the end then we need to set it together, solve and remodel it maybe. Now, the steps to be followed is, in the problem analysis, yes, I showed the details. Most important, sketch the problem and the respective control volumes. Formulate a balance, write it down. Use either view factors and surface brightnesses or the net radiation fluxes. Then, for the surface brightnesses, use a sketch, as I did also here in this example, to determine it. Then formulate the view factors, and in this fifth step, the solving. If solving is required, then you are asked to put 4 and 3 into the balance too. If this is not required and you should just define the equations, you can skip step 5. And I really encourage you, in the balance, work with surface brightnesses as a variable. Do not put in the values calculated unless you are asked to solve it, because that just overly blows up the equation, and this is then prone to errors. And I hope that this is a good guideline for you. So please reflect here about the most important points that are needed to be clarified before you even start calculating radiation tasks. Thank you.